So hello everyone, in this video we'll be solving the first three problem of today's LeetCode Biweekly Contest 170, and in this contest I was able to solve A, B and C problem. The fourth problem I didn't get enough time to solve that. If I solve that fourth problem, I'll be making another video on that, but in this video I'll be discussing the first three problem solution. So let us see the first problem. The problem name is minimum number of flips to reverse binary string. Now it is just an implementation based problem. So you are given an integer n, and let's say s is the binary representation of n without leading zeros. Now the reverse of a binary string s is obtained by writing the characters of s in opposite order. That means just reverse the the orientation of string s. Now you may flip any bit in s and change it, like 0 to 1, 1 to 0. Now each flip affects exactly one bit. That means if you are changing 0 to 1, that means only one bit at a time can be changed. Now it is not that all zeros will be changed to 1, only one bit at a time will be changed. Now you need to return the minimum number of flips in order to make s equal to its reverse. You need to make s is equal to its reverse form in binary representation. This is what the question is saying. Now this is pretty much straightforward. So you are given an integer n. So first what you need to do, let's say the n given to you is let's say 7, not 7 would be very easy case because it is all 1. Let's say 11. So its binary representation will be 1 0 1 1. This is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, and this is 2 to the power 3. So this will be 8, this will not take into our account, this will be 2, and this will be 1. So 8 plus 2 is 10 plus 1. So this is the binary representation of 11, 1 0 1 1. Now first we will make the binary representation. So this will be the string s. Now we need to reverse that. So reverse of string s, let's say we name it rev s. So that would be 1 1 0 1. Now it is obviously sure that if we need to make s equal to reverse of s, we need to change each and every bit that is not equal. So in this case this is equal, so we won't change it. In this case this is not equal, so we will change it. In this case it is not equal, so we will change it. In this case it is equal, so we will not change it. So in total we will be requiring two operations, and it is obvious that if we are changing only necessary bits, so that will be the minimum answer only. So in this problem you just need to find the binary representation and then the reverse reverse orientation of that, and just change the bits which are not equal in their corresponding places. So let me just show you the code now. So yeah, this was the first idea what I had during the contest. So you might think that this is the long code, but yeah, you can optimize it. This is what that comes first into my mind, so I just implemented that without thinking too much. So you can just optimize that. So initially we have string s empty. If we are having bit set, so we are including 1 into the string, otherwise we are adding 0 into our string. Then we are reversing the s, the binary representation. Now in the binary representation it can happen that because we have checking for 32 bits, so it will happen that let's say for the 7 its binary representation is 1, so you might get 0 0 0 1 1 1. So this would be the actual s that you will be getting, right? Not actual s, you need to first reverse that. So this would be the binary representation what you will be getting. So you need to remove this these zeros that are in front. So this is what I have done, just remove the front zeros, and yeah, just take the reverse of that. So we are taking the reverse. This is what our rev s was actually, and if currently both are equal, so we don't need to make any operation, we'll return 0 from there. Otherwise, what all places have opposite signs, let's say here it is 0, here it is 1, so in that place we need to change the bit, so we'll increasing our count, and in the end we are just returning the count. So this was pretty easy question. Just take the binary representation of s and reverse of s, and at every position check whether the bits are equal or not. If they are equal, it's okay. If they are not, increment your count and just return that count. So yeah, this was the first problem. Let us see the second problem now. So this is the second problem. The name is total vividness of numbers in range, and this is the first part. The second part I couldn't solve due to lack of time. I barely had like 10 to 15 minutes left. So yeah, let us read the problem statement. So you are given two numbers, integer numbers num1 and num2, representing an inclusive range num1 from num2. Now the vividness of a number is defined as total count of its peaks and valleys. Now a digit is a peak if it is strictly greater than both of the neighbors. A digit is valley if it is strictly less than both of its neighbors. Now first and last digits cannot be peaks or valleys because it will not have any neighbors to its left or either to its right. Now any number, if it is fewer than 3 digits, the vividness is 0, because obviously we won't have either of them, either right neighbor or left neighbor. So yeah, in that case the vividness will be 0. Now we need to return the total sum of vividness of all numbers in range, including from num1 to num2. Now this is also just the implementation based problem. So let me just show you what I have done. So you need to just loop through from like num1 to num2. Now this is the number in integer range, so you need to first convert it into string. Let's say let's like dry run on this example only. So let me just clear this out. So this is the number num1 equal to 120 and num2 equal to 130. So we'll be checking each and every like number 120, 121, 122, 123, 124, 125, 126, 127, 128, 129 and 130. So we'll first check 120. So we'll starting from first index. So this is the first index. It is greater than its left and right. So this is peak. So we'll increment for the peak. Then we will have 121. This is the first index. So it is greater than its left and right. So we'll increment the peak count. Then we will have 122. So this is greater than the left part but not greater than the right part, so it is neither a peak nor a valley. Then we'll check on 123. This is neither peak or nor valley. We can check on to each and every number. Again that we will get one peak is the number 130. We'll be checking this. This 3 is greater than 1 and greater than 0. So we will find one peak. So in total we have 3 peaks. So we'll be returning 3 as our output. Now it can also happen that if we have some number, let's say num, then it can have peak also and it can have valley also. It can have multiple peaks as well, it can have multiple valleys as well. So yeah, we just need to just convert each and every number to string and count how many peaks and valleys are there. For peaks we will just check the current like num of I is greater than both I plus 1 and I minus 1 or not. And for valley we will check whether num of I is lesser than its both num of I plus 1 and I minus 1 or not. If it is, we will just increment the corresponding count and we will just add it to our final answer. So this is also just the implementation based problem. So let me just show you the code now. So yeah, we are starting from here. This is the main function that we want to solve. So initially our answer will be 0. We'll be running loop from num1 to num2 and we'll first convert each and every number that is I to string, and that for that particular number that is in string form we will count its peak and valley and add it to our answer. In the end we'll be returning the answer. And how we are finding the peak and valley? We are just checking the initial base case. If the size is lesser than 3, that means it can't have any peak or valley, so we'll be returning 0 from there. Otherwise we are declaring two variables, peak and valley. Now we'll be running loop from 1 to size minus 1, because yeah, we need to start from index 1 and go up till n minus 2. These will be the set of like valid indices that we need to check. Now if s of I, that means this s of I is greater than s of I minus 1, that is s of I minus 1, as well as this is greater than I plus 1, that means it is a peak. So we'll be incrementing the count of peak. If it is lesser than both, that means if it is something like this, that means it is a valley. So we'll be incrementing the count of valley. In the end we'll be returning total peak plus valley and we'll be adding to our answer. We'll be doing for each and every number, and in the end we are just returning the answer. So this is how the solution works for the second problem. Now let us look on to the third problem. This is the third problem, and this is actually a good problem because it has some mathematical kind of intuition behind that. So that what makes this problem a little bit difficult from the other two problems. So the problem name is lexicographically smallest negated permutation that sums to target. So let us read the problem statement. So we are given a positive integer and an integer target. Now you need to return the lexicographically smallest array of integer of size n such that the sum of all the elements is equal to target and the absolute values of its element is permutation of size n. Now what is a permutation? Let's say the n is given to you is 3. So its permutations is nothing but the combinations, like the different combinations of numbers from 1 till n. Let's say 1, 2, 3 is permutation. 3, 2, 1 is a permutation, 2, 1, 3 is a permutation, so on and so forth. This is what the permutation is, and we need to find the lexicographically smallest of these array. We can have negative numbers as well, because if you look at the constraints, the target can go up till 1e10, minus 1e10, and it can go as max to 1e10, plus 1e10. So we can have negative numbers as well. That's why they have written the absolute value of the elements. Now if no such array exists, you just need to return empty array. Then they have given the definition of what is lexicographically smallest and what is the definition of permutation. So this problem is actually very good. So let us understand with the help of this first example, where n is given to us 3 and target is given to us is 0. Now just tell me, if you have given value of n to be 3, what are the set of possible numbers? The set of sorry for that, let me just erase that. So the set of possible numbers could be 1, 2 and 3. So let us say that we have these set of numbers, and what can be the maximum sum that we can make from these numbers? That will be nothing but n into n plus 1 by 2, right? This will be the maximum sum possible. In this case it is 3, so the maximum sum possible can be 6, but we want to achieve the target, which is 0. So what is the actual difference that we have here? The actual difference we have is of 6. Now let's say we have all positive numbers in the beginning and we have the difference of 6. Now what do you conclude from this? You conclude that there will be some numbers which are positive. Currently we have all number positives. That means we need to make change of the signs of some of the positive numbers. That means we need to change some positive numbers to negative number. That when we will get the our actual sum equal to target, because currently our total sum is what, 6, which is greater than the target 0. Now if it's greater than 0, that means we need to negate some numbers, right? That's why we'll be just changing the signs of biggest possible positive values. Now why biggest possible positive values? Because we need to return the answer in smallest lexicographical order. So what can be the biggest positive number? In this case it is 3. So if we negate this will be the biggest negative number as well, and if we put this first, we have higher chances of getting the smallest lexicographical order. So this is the idea behind this solution. So let me just tell you step by step how will we do it. So we'll take this example only. So here the n value is 3, target is 0. I'll explain you step by step how we'll be solving this question. But so what is the maximum sum that we can get? The maximum sum that we can get is n into n plus 1 by 2. What is the target? Target is 0. So what is the difference? So difference is nothing but this sum minus target. Now this is what we want to achieve, right? Now just tell me one thing, if we are changing a positive number to a negative number, what change it will bring to this particular sum. Let's say if you are changing -2 to +2, so actually you are making change of 4, which is nothing but twice the original number if you take the absolute value. So let's say if you have some number -x, you are changing it to +x. So actually you are making change to the sum twice of that original number. So this is the main idea behind this problem. So we need to have difference of DIFF or diff. So what we will do now, what this diff will be? This will be the summation of some numbers, right? x1, x2, which are positive actually, x3 till let's say xn. Now what this difference is? This is nothing but after changing the value, and if you are changing the value it will bring twice the change, because we have just seen if you have some negative number x, we want to make it positive, it will bring twice the change of the original number to our actual sum. So if you are just saying that I have a -2, I change it to +2, so in your actual sum you are making twice the change, because first it will make -2 to 0, then it will bring 0 to 2, so 2 here and 2 here. So this is how it is working. So you can say that this DIFF is nothing but changing the signs of some values, which will be twice contributing to our actual diff, right? This is what it is mean. Now if you can see this equation, what you can say, the actual summation of these negative numbers is nothing but x1 plus x2 till let's say x whatever is nothing but diff by 2, right? From this equation we can just divide it by 2 here. Now this is what we actually need. Now what this equation says, will be changing the sign of some positive numbers to negative numbers, and that negative number sum will be what? It will be nothing but difference by 2, and that is what we want to achieve. If we achieve that, that means we will achieving our target, right? This is what we need to find. So we will check each and every positive number, we will try to negative it, and this is what our need. Let's say we store it in some variable need. This is our need, and we also subtract that particular number from our need as well. Let's say we made change for like positive x to negative x, so we'll also reduce x from this need because we have already made it negative. And when this need will become 0, that means we have no difference left, and if we have no difference left, that means we have achieved our target. So if you didn't understand this question, so let me just show you the dry run of this first example, and then you will understand in more better way. And also one thing, since we need to make the smallest lexicographical order, will not be choosing any random positive number, will be choosing the largest positive value first, because if we are making the largest positive value negative, this will have more chances of making our lexicographical order more smallest. So this is how we will approach greedily. So let me just show you the dry run, and then you will like understand in more better way. So yeah, so n is 3, target is 0, so sum is initially 6 and target is 0. So yeah, so the difference is 6. Initially we have all elements positive in our array. So what we need to actually make, we need to change some positive numbers to negative, and that to the largest positive number first. So what is our actual need? Our actual need is difference by 2. So what is the need? Need is 3. Now don't get confused, this need is nothing but sum of negative numbers which are actually changed from positive, nothing else. So let me just show you. So this is the highest positive number, right? So currently we will check whether this particular number is less than or equal to our need or not. If it is, then only we will change, otherwise we won't change. Otherwise this need will become negative, and we don't want that. So yeah, it is currently equal, so we will change this particular number to negative, and we will maintain two vectors, one for negative and one for positive. So in our negative array we'll be pushing -3, and we'll be subtracting need from our we'll be subtracting this number from our need. So need minus equal to 3. Now our need becomes 0. Now when our need becomes 0, that means we don't need to make any changes. So we will just push the remaining elements into our positive vector. And since we need the lexicographically smallest element, we will first push all the negative numbers, then we'll be pushing all the positive numbers. So first we will start with negative. 3 is the only element, then we'll be starting from positive. So in positive we have 1 and 2. So this is the final array that we will get. Now what I have told you initially, this need is nothing but the sum of elements which we are changing from positive to negative. So what value we change from positive to negative? This value 3. So this is the only value 3, and if you take this sum, it is nothing but 3, which is actually equal to our need. So this is what the problem is. It is little bit difficult to understand this problem initially, but if you will try out on some like test cases by yourself, you will understand it very easily, because there is some mathematics behind this. So a lot of equations will be going, so you need to try out one time for yourself, then only you will be understanding. Because in the contest also I took almost 1 hour on this problem, and I had like 3 wrong submissions. So yeah, it is a little bit tricky problem because it has lot of equations in it, but yeah, you need to dry run on some of the examples, then you will be able to get how these equations and all that are coming. So yeah, this was the problem. Let me just walk you through the solution as well, the code part. So yeah, initially we will be taking a sum which is n into n plus 1 by 2. Then we will be taking difference, that is nothing but sum minus target. And yeah, if this is the edge case, right? If our difference is negative, that means we can't make the target because it is already less. So and we own all the elements are positive, so we can't make it more positive, right? So yeah, this is the edge case, so we'll return empty array from there. And also if the difference is odd, then also we'll be not able to make it, because why? I have told you, if we are making some positive number to negative, it will contribute twice to the diff. So that means that diff should be divisible by 2, right? So that's why this diff can't be a odd number. So that's why this is the edge case as well. In these two cases we'll be returning empty array. Then we are taking two vectors, negative and positive, and we are calculating our need. This need is nothing but sum of all the elements which we are changing from positive to negative, which is nothing but diff by 2. Then we'll be iterating on the loop, taking from the maximum positive value first and going out till the smallest one. So first we will check whether our x is less than equal to our need or not. If it is, then we will make it negative and push it into our negative vector, and we'll subtract it from our actual need. Otherwise we'll just push it into our positive vector. In the end we'll be checking if our need actually becomes 0 or not. If it is not become 0, that means we can't find it, so we'll be returning empty array. Then we'll be sorting this negative and the like positive vectors, because we need the answer in lexicographically smallest order. So yeah, that's why we have sorted them. And in the final answer we will be first pushing all the negative elements, then we'll be pushing all the positive elements, and that's why that's how we'll be getting the lexicographically smallest order. And in the end we are just returning the answer. So yeah, these are the first 3 problem solution in this particular video. And yeah, this third question is a little bit tricky to understand, because you need to try out some dry run on some test cases, so then only you will be able to understand. I have tried my best to explain. So yeah, thank you for watching.